official plural. Frankly, I always just say that. So Diplococcus is 2 cocci. Streptococcus, and yes, that is what causes strep throat, is a chain of coccus bacteria. Tetrads are 4 of them. And then Staphylococci. This isn't really quite correct what I have. I have sheets. Really, a better term is probably clumps. A sheet implies something flat. That's not flat, it's a clump. You'll see a picture like that. So up there you see Diplococcus, Diplococci, Streptococci. You can see it's a chain, and they really are chains. There's a tetrad. I didn't give you this. This is Sarcenae. Basically 2 tetrads. 8 of them. And here is the Staphylococcus. Like I said, it's really more of a clump than a flat sheet. The point of it is a lot of variation. A lot of variation. Bacillus, you can do the same thing, although not as much. Whoops. You can have Diplobacillus, Streptobacillus, or bacilli. The US is singular. The I is plural. And if you've had A and P already, you saw that a whole bunch. So Bacillus, Diplobacillus, looks like, string of hot dogs, Streptobacillus.
Yeah.
And this one, Coccobacillus. First C is pronounced hard, second C is pronounced hard, third C pronounced like an S, Coccobacillus. Basically, it's 2 cocci together, but they're so closely bound, it looks like a bacillus.
So what is it?
Coccobacillus. And that's what it is. So the point of it is there's a lot of variation. Same thing I said a minute ago. And this isn't even the beginning of a complete listing. And then there's spiral or vibrio. Those actually, the vibrio are actually comma shaped. Comma shaped. Spirilla is spiral, spiral staircase. Spirochetes. Well, these are the ones I gave you, or maybe I didn't, I can't remember. Spirochetes is like this. It's kind of bacillus. 2 pairs of flagella. But the flagella go inward. It's very unusual. Usually the flagella come out like tails. These guys go inwards, and they kind of wrap around the bacteria. And when the bacteria wants to swim, it kind of coils up like this. The flagella kind of wrap around, and then it straightens out, and the flagella kind of uncoil the bacteria, so it goes swimming through the water like a propeller. And that's the way it swims. So it coils up, straightens up, coils up, straightens up, because of those flagella. It's very unusual. So anyhow, all of those would be miscellaneous, other variations. So that brings us now to what's called the glycocalyx. The glycocalyx. Glyco means sugar. This is a sometimes thing. A sometimes thing. Obviously, you know all cells have a membrane, cell membrane. Bacteria have a cell wall. Now, in addition, maybe, sometimes,
Capsule.
you'll have a glycocalyx. Maybe yes, maybe no. Surrounds the cell wall. It's mostly made of polysaccharides. It's mostly made of polysaccharides. Now, polypeptides can be in there also. So you can see maybe both. But frankly, it's mostly polysaccharides. That's why glycocalyx. Yeah.
So this is the same as the capsule you were talking about last
In
time?
fact, I'm coming right here. If the glycocalyx is firmly attached and very well organized, it is the capsule. If it's not so well organized, and once again, variation, if is not so well organized, it's called a slime layer. So in honesty, we'll be talking mostly about the capsule. The glycocalyx is the capsule. It could also be a slime layer. Depends on how well organized. We'll stick with capsule. There's a lot of different functions for a capsule. One is adhesion, stickiness. I'm sure sometime in your life you've spilled sugar on your kitchen table and then somehow got water in it or something. Wet sugar is sticky. Well, so is the glycocalyx sometimes. A glycocalyx can cause adhesion or stickiness. The bacteria causing tooth decay use that. That's how they stick to our teeth. It won't surprise you, since it's made out of carbohydrates, to know that the capsule can also be used for nutrition and be used as an energy source by the bacteria. The capsule can protect the bacteria from phagocytosis. Remember, the macrophage, in doing phagocytosis, surrounds the bacteria, tries to swallow it. I know I just said the capsule can be sticky, but I also said it's got many functions. In this case, the capsule can be slippery. So basically, the macrophage tries to surround it, and it can't do it. The bacteria is slippery with the capsule. It squirts right out of there. It squirts right out. When I was a kid, I used to like to squirt watermelon seeds through my fingers. Pissed off my mother, but anyhow, it was kind of the same thing. It'd be so slippery, and you just squirt as far as you can. Essentially, that's what happens with a macrophage trying to eat a bacteria with the capsule. So the capsule can be both slippery and sticky. Now this, in one particular case, the pneumonia bacteria. If there's no capsule, it does not cause pneumonia. You don't get sick. Now, I'm going to give you some information. I will challenge you to come up with the correct conclusion. I said wrong because I already know that when you come up with the correct conclusion, it will be wrong. So, it's why your teacher's here. So, here's the information. Bacteria with the capsule will make you sick, you get pneumonia. A bacteria without the capsule, you do not get pneumonia. You do not get sick. So I would challenge you to not come up with the conclusion the capsule causes the pneumonia. With the capsule, you get sick. Without the capsule, you don't get sick. But in actuality, like I said, that's actually the wrong conclusion, although it's the obvious conclusion. But it's the wrong conclusion because the capsule itself actually has nothing to do with the disease. What the capsule is doing is preventing the bacteria from getting eaten. So with the capsule, the bacteria is not eaten by macrophages. Therefore, it survives long enough to cause the disease. Without the capsule, the bacteria simply gets eaten, and therefore no disease. So that's why I say, it really, just based on what I gave you, it sounds like the capsule should cause the disease, but it doesn't. It simply will keep the bacteria alive long enough to cause the disease. I think I have that. No, I don't. So bacteria with the capsule makes you sick because the bacteria escapes the macrophages. The bacteria without the capsule does not make you sick because the bacteria gets eaten. Any questions on that? Is that okay? Okay. Now this one. The capsule material is genetically determined. Does anybody know exactly what does the DNA do? Now, of course, heredity, we all know that. What is the exact mechanism? what is the function of the DNA? The actual function is to make proteins. Is to make, pardon me? Is to make proteins. Now, there seems to be a conflict here because obviously we've been saying ribosomes make proteins. And now I'm saying DNA does. Well, in reality, the DNA does not directly make proteins. The DNA gives the instructions to make proteins. It's kind of like an architect. An architect does not build houses, but he draws up the blueprints. He makes the plans for building the house. And then he gives those blueprints to the contractor. The contractor builds the house. That's what the DNA does. The DNA contains the blueprints. It contains the instructions to build the protein. The instructions will be given to the ribosomes. The ribosomes follow the instructions and build the protein. So really, even though if I ever ask you what makes proteins, the answer is ribosomes. But the DNA is responsible for it. Just like the architect is responsible for building the house.
Would that do something with RNA?
Yeah, I'm not going to go there right now, but yes, the DNA gives the instruction to the RNA and so on. But
Sorry, last quarter.
for a much later time, yeah. So anyhow, so the overall function for the DNA is to help build protein. So the capsule material being genetically determined, that pretty much implies, even though the capsule is mostly carbohydrate, and it is, but there are some proteins. It's not unlike the membrane having a bunch of things besides just phospholipid. There are proteins in here. And proteins, I'm sorry, in the capsule, yeah. There are proteins in the capsule, even though it's mostly carbohydrate. And protein is always subject to mutation, with DNA. Always subject to mutation. So you might end up with different capsules. The carbohydrate might always be the same, but the protein might be different. And that leads to this. This is an extreme case. The Streptococcus pneumoniae has 70 different serotypes. Now, serotype is a new word we haven't used, but a serotype really refers to the interaction between antigen and antibody. Antigens are the bad guys, bacteria, viruses, other things that try to make us sick. The antibodies are the good guys, part of the immune system. They fight the antigens. The serotype is basically an antigen, but the overall concept is the interaction between antigen and antibody. So, every time the proteins change in the capsule, essentially you're going to make a new capsule. Even if the carbohydrates are all the same. Changing the protein means you change the capsule. If you change the capsule, you have changed the antigen. The immune system identifies the bacteria by what's around the capsule, or what's in the capsule. So if you change the capsule, you change the antigen. The bacteria itself might still be the same. In fact, it will be the same. But what surrounds it, what the immune system is using to identify the bacteria, that has changed. And that means you get a new antigen. So 70 different serotypes basically means 70 different capsules, and that means 70 different antigens. The bacterial cell itself is probably the same cell, but the surroundings have changed. It's just kind of like if you go to the store and you buy new clothes. It's still you, but the clothes have changed. So your outer appearance has changed. And that's kind of what this is. The immune system identifies the bacteria by the outer appearance. So 70 different antigens means 70 different antibodies. Anytime you change the antigen, you must have a new antibody. The immune system is very, very specific. You can see the capsule does a bunch of different stuff. The expression of the capsule. Maybe the bacteria actually has a capsule, but not all the time. It can be environmentally influenced. Now, the prime example is Streptococcus mutans. Streptococcus mutans, that's the tooth decay bacteria. It only makes a capsule in the presence of glucose. So all those times your mother told you quit eating candy bars, she was right. Because the more candy you eat, the more sugar you eat, the more likely it is that the Streptococcus is going to build a capsule and then start eating away at your teeth. No, frankly, it's very difficult to truly get rid of sugar in your diet. Yeah, you don't have to eat candy bars in order to get sugar. If you eat an apple, you're getting fructose. If you eat some cheese, you're getting lactose, and so on. So there are other sugars, but obviously you can minimize how much sugar is in your diet. So yeah, that's an example of environmental influence on the capsule. Questions so far? Oh, okay, this was not my best effort. In fact, it was such a rotten effort, I don't even want to read it. What I was trying to say here, and I should just get rid of it, I always forget. What I was trying to say is that the capsule not only protects from macrophages, it can also protect from viruses. Bacteria get hit by viruses just like we do. And the virus that hits a bacteria is called a phage. A phage is specifically a bacterial virus. Bacteria virus. So we, for example, do not get hit by phages. Now so we get hit by animal viruses, and that's what they're called, animal viruses. But the phages are bacterial viruses. So the capsule is a barrier. It can protect both from macrophages and from viruses. That's what I was trying to say. I just didn't say it very well.
And it says the phages bind to the cell wall.
Correct.
And the capsule can bind to the
Correct.
cell wall.
Correct. Yeah, exactly right. What she said is because phages will bind to the cell wall, but with the capsule, it can't.
But we can get hit by animal
Viruses. Oh yeah, I mean, obviously we do, but they're called animal viruses. Yeah. Okay, good job.